Hello, I'm Thierry Trollier, President and Technical Manager of Absolut System in Grenoble. It's a great pleasure to present you our advanced cryogenic equipment, XCube, developed for low temperature science. This week, Absolut System is celebrating its 11 years birthday. We are growing faster every year, reaching 3.5 million euro turnover in 2020, and we are about 30 people today. Most of us are engineers with high skill in cryogenics and thermal management. We master complete cryogenic value chain, and we are developing and mastering key technologies such like cryocoolers, cryostat, cryofans, heat exchanger, thermal link, and so on. All these components are optimized to form complete tailor-made integrated systems for various markets. We currently work for numerous agencies and research centers as we have high product assurance management audited by the Prime. We meet challenges of performance, time, and quality on complex projects. Absolut System is part of XTech Group. Nevertheless, we develop end-to-end solutions offering all the advantages of an assembly, such as flexibility and adaptability. XTech Group defines the foundation for a more sustainable future by innovating every day to provide tomorrow's technology and overall solutions. Our main domain of expertise are aerospace, mobility and energy transition, quantum computing, and superconductivity. We ensure tailor-made engineering services, development and commercialization of custom design-made solutions. Our teams work every day to innovate and offer specific equipment that cannot be found on the shelf. One of them is the XCube. Let's know more about this advanced cryogenic equipment and its low temperature application for quantum computing. Let's present XCube product. Advanced cryogenic equipment, XCube, is a versatile cryogenic platform. It is a cryogen-free cryostat with no liquid nor gas consumption. It is based on Absolut System helium cooling loops developed for low temperature science. Compared to conventional solutions based on metallic conductive links, this solution has double advantage. First, to move the cooler away from the instrument while minimizing the footprint occupied on the optical table. Second, to reduce the mechanical coupling with the cooler and therefore to minimize exported disturbances induced by the cryogenic system. By mastering the components, Absolut System can provide a cryogenic solution that meets your application requirements. This vibration-free solution can be totally customized depending on the requirements: experimental volume, cryogenic power, and low temperature. Absolut System has developed several helium cooling loops configurations depending on the final application to meet these different requirements for infrared detectors cooling, where the vibrations are an issue. In this application, a cryogenic circulation loop is used to distribute the cooling power while mechanically decoupling the source of vibration, the cooler, from the application, the detector. Superconductive cable, motors, and magnet application for which a large cooling power needs to be distributed over a long distance. Large cryopump for which the cooling power at 20 to 40 K needs to be distributed on large surfaces to cryopump gases in vacuum test chamber. Vibration-free closed-loop cryostat for low-temperature physics in the 1 to 40 K region. The XCube concept comes with the development of numerous remote helium cooling loops or supercritical helium cooling loops. Few bars of helium gas are circulated by a cryofan from the cold box, where the gas is cooled by a cryocooler, to the application cryostat via a high-efficiency vacuum-insulated flexible line. Using a 4K cryocooler, the limit in temperature for the application is around 5 to 6 K. Thus, for 4K and lower temperatures, a Joule-Thomson expansion stage, so-called GT, is added as shown in the following slide. With the addition of the GT stage, the temperature is driven by the gas, helium-4 or helium-3, and the lower pressure of the GT pump, while the cooling capacity is driven by the mass flow. It shall be noticed that for 4K application, this concept of GT pre-cooled by 10K cryocooler has already proven better efficiency than a 4K regenerative cryocooler, whatever it's a pulse tube or a Gifford mat mount. Now, what are the XCube products we propose? XCube products are proposed as function of the temperature. The 10K system with 4K pulse tube cryocooler and using supercritical loop. Such a system using a 10K pulse tube has already been delivered and commissioned beginning 2020 in Paris Polytechnic School for characterization of semiconductors under magnetic field in the 10 to 20K temperature region. A 4K system with a pulse tube and a 4K GT cooler for which a demonstrator is currently under test using a 15K Gifford mat mount as pre-cooler, and a 2K system using 4K pulse tube and 2K GT cooler. This system is under development and will be presented in the following slide. For sub-Kelvin temperatures, the system can make use of helium-3 instead of helium-4 in the Joule-Thomson stage. A system with 100 mW cooling capacity at 500 mK is under development in collaboration with CNRS Neil Institute. A presentation is given by Philippe Camus in a companion paper in the course of the present conference. Furthermore, a continuous adiabatic demagnetization refrigerator or a dilution stage can be added to reach temperature lower than 500 mK. Let's focus now on 2K XCube platform. 2K XCube platform is a cryogenet-free solution with no liquid nor gas consumption. It provides 50K and 2K force flow loops, minimizing the vibration transmission to the application and suppressing the low frequency 1.4 Hz exported from the cryocooler conductive coupling, which is very difficult to damp. Moreover, DC flow enhances the temperature stability compared to the low frequency temperature sweep of the cryocooler, which it shall also be done. The tabletop design provides large custom sample space for the user with an easy access. 2K XCube provides a powerful 50 to 80K stage for thermal shield and other user loads. The system can be customized with optical windows, magnetic shield, micro-positioning, temperature control, and so on. Let's detail now the flow process. The flow process is composed of two separated helium loops, both using helium-4. A 50 to 80K cooling loop using a cryofan designed for 10 watts cooling power with a mass flow of 200 mg per second. A Joule-Thomson cooling stage using a dry scroll pump designed for 100 mW at 2K with a mass flow of 5 mg per second. Due to the inversion temperature, a lower cool-down flow, in blue in the schematic, shall be used to couple the PT second stage to the application for pre-cooling to a temperature below 10K. Then the normal GT cooler flow can be operated to reach the lowest temperature. Now I will present you the various components of the system. The 2K system comprises the following components. First, a cold box with a two-stage high reliability pulse tube cryocooler PT410 remote motor type from Cryomec that we represent in most of the European countries. A cryogenic circulation fan from our production, various heat exchanger and cryogenic filters for the GT stage. Second, a high efficiency vacuum insulated flexible line. And, at last, the application cryostat with a GT cooler and recuperative heat exchanger, an actively cooled thermal shield, vacuum insulation separated from cold box and flexible line via a vacuum barrier, and various electrical connectors and feed flows. In the 2K XCube platform, we have three different tailored technologies. First, we use custom-made high-reliability and high-performance cryogenic circulation fan, designed, optimized, and produced by Absolut System. Then we have efficient recuperative heat exchangers, tube-in-tube or additive manufacturing technologies, depending on the mass flow. Finally, efficient thermal coupling with the pulse-tube cryocooler is achieved thanks to incorporated heat exchanger or thermal intercept. Now, what is needed for the 2K XCube to operate? The 2K platform needs a gas handling system to manage the pre-cooling and cooling phases by controlling the mass flow, to protect the pump for an overpressure, to fill and clean the pure helium gas for the GT cooler, to manage pure helium storage at room temperature. It is a compact arrangement in a rack comprising the cold box, scroll pump, gas storage, plumbing, e-valve, and so on. It provides an autonomous PLC for the system controls, measurements, and display. Let's focus on the application of the low-temperature remote cooling solution. Using our remote cooling concept, our XCube has a disruptive approach for integration and scalability of various applications. It addresses scientific applications like cryo-optics or material testing, cryoelectronics applications, superconducting applications such as squeeze or RSA-Q, superconductive qubits, qubits CMOS type or asperlated technology, qubits control electronics, low temperature instrumentation like high resolution spectroscopy, terahertz or millimeter wave imaging, and any other low temperature application that you may have. We'll be pleased to work on your specific requirements. If you have any question, please use the chat and we will reply to you directly. For more details on Absolut System offers, you can have a look on our website and feel free to contact us. Have a great time on World 14 workshop.